The green features, everybody talks green today, so we have the electrical steering system, the hydraulic oil in that one. We have the leakage monitored sealing system, or leak-on system. We have the improved mechanical efficiency and the high motor efficiency in partial and full load. So these are the tug boats which we equip with the combi drive for Switzer. And here we see the general arrangement. That's a nice view with the diesel engine, the auxiliary generator, then the switchboard, and the thruster room. So in the smaller version we have 2,100 kilowatt each for a bollard pull of 71 tons a head. And for the bigger one, the stern thrust was critical, so there we give 75 tons astern and should be at least 80 ahead. So now we come to the fixed pitch propeller hybrid solutions. We have 4 different solutions. One is with the electric motor integrated into the shaft line. Then we have the version with a high-speed engine and a hybrid gear. Then the pure diesel hybrid system. And we also work with the thruster with the electric PTI. So this is the solution with a specially designed electric motor integrated into the shaft line. The advantage is that we have here, for an example of an 80-ton tugboat, a shaft speed of 16 to 1800 RPM, and we would use the diesel engines of 2.2 megawatts plus then 400 kilowatt electric motor power. So all these ideas with the hybrid solution have the goal to reduce the diesel engine, the size, so the operating hours of the main engine are reduced considerably. We have redundancy in the propulsion lines. We have, let's say, the slipping function by the electric motor. We have the smooth clutch engaging. Firefighting is possible, and we have a simple shaft line design because we don't need any bearings. The electric motor then also covers the function of the shaft bearing. Evidently, the disadvantage is a specially designed electric motor. So this is an idea we play with. We have no execution of it already, but we'll see how it comes out. Here we have some examples for such arrangement. With the 1500 kilowatt propulsion engine, for instance, frequency controlled motor of 400 kilowatts, and then the gensets at the various frequencies. Okay, the other solution is a high-speed engine with a hybrid gear. So that's like in any conventional hybrid design with a fixed shaft line, so frequency, speed controlled electric motor, and so for, let's say, standard supply vessels in hybrid design, that's already an established solution. And this is what we have under construction here for Fairplay, the solution. So this is a Pi-5 gearbox, and let's say the system integration or the intelligence is to define the various reduction ratios to match the capacity of the electric motor with the torque to the fixed pitch propeller curve. So we have various operating modes in transit with the electric motor only. We have the boost motor, so diesel plus electric motor, where the diesel engine is the master. We have evidently diesel engine only, and in firefighting we use the electric motor to keep the position of the tugboat, and the diesel then drives the Fifi pump. This is what we see is the arrangement with the highest flexibility. The PTI reduction ratio is adaptable to different diesel engine and electric motor speeds. So from case to case, this is, you mentioned, you have to integrate every possible supplier. We offer the PTI from 400 kilowatt to 1 megawatt, and then the diesel engines will be in the range of 1.5 to 3 megawatt. And this is one design example with the stern-driven tugboat. The tugboats now under construction for Fairplay are tractor tugs, so with a shorter shaft line. Then we have the diesel hybrid system, where we replace the electric motor by a diesel engine, and this we have not under contract yet, so this is an idea we play with, but in my view that is particularly charming, because whenever you involve electric systems you have the electric losses, and they are also rather expensive. So if you get away with a pure diesel solution, then that's a rather straightforward and efficient way. Basically, this is what you do in father and son applications, also in conventional systems. So the problem then with fixed pitch propellers, the problem here evidently is to design this system for a fixed pitch propeller. That's the tricky part. For a CP propeller it's easy, but for a fixed pitch propeller this is the demanding case. Then with the hybrid gear with 2 reduction steps for the hybrid or the small diesel engine. So again we have the transit mode with a small diesel engine only, and with a high PTI reduction, so we have to reduce the propeller speed not to overload the diesel. We have the boost mode, where then we use the low reduction to match the engine speeds. And again we have the FIFI mode, where they can work independently, small and large diesel engine. Okay, so for all these hybrid systems, again the story that considerably reduced operating hours for the large diesel, and we have the reduced emissions and fuel consumption. I mean, that's all the same arguments. Again, disadvantage here clearly is the complex mechanical solution. And the last one, that's with our PTI. We use PEM, so permanently excited magnetic motor. For the PTI, we have hydraulic disengaging clutch at the power input, and we have shaft speeds of 1600 to 1800 RPM, and we use this for 2 thrusters only, the latest developments of Z drives. And for all the hybrid systems, the design of the whether that's the small diesel engine or the electric motor that we use as a PTI or for the gearbox, it is designed in such a way that we achieve a tugboat speed of about 10 knots, more or less. That's the target. Because in harbor service, no tug has to run at 13 knots. That's a waste of energy. And on the left, we see the power requirement for the speed of 10 knots for a stern-driven tug, and on the right side for a tractor tug, which has a higher resistance. So we come up to 325 kilowatt in the example for the stern-driven tug, and 585 for 10 knots in the tractor tug. So the 460 kilowatts that we offer with our PTI are a good compromise to be near the 10 knots. So for free sailing, when the tugs go out to pick up the vessel. So this is what we use. Then for a 65 tons bollard pull tug, we have diesel engines with 1500 kilowatts, the electric motor with 450, And for 90 tons, that would then be 2,240 kilowatts with electric motor of 450 kilowatt. And the ship speed is then between 9.3 and let's say 9 and 11 knots in that range. And this is the tugboat where we have realized this design with the PTI. That's the Eddy tug, developed by a Dutch designer, built in Holland, and that will also be introduced in Hamburg for the ITS. So I think then you can take a harbor tour. I don't know who else will be invited, I have no clue, but they want to present that in a big way. So advantages of the hybrid solution. That's the green technology, no partial load operation for main engines and generators. We can use the main engine one size smaller with lower investment costs on main engines, substantially reduced operation hours for main engines, increased TBO, same as you argue, I mean, that's clear. Reduced fuel consumption in transit mode, reduced emissions, double redundancy by electric motor and diesel engine, raised comfort on board due to reduced noise, and increased bullet pull due to the boost mode. That's it. Thank you.
Yo solamente para terminar agradecer a Halsevers, a Cavallia y a Rotación la oportunidad que nos habéis dado, y si tenéis cualquier pregunta que os pueda contestar Halsevers, seguidnos aquí, un poquito más tarde en el stand que tenemos, estáis invitados y bienvenidos a cualquier cosa. Muchas gracias.
Bien, gracias a todos. Teníamos como último invitado a que nos